In this lesson, we are going to learn about characteristic X-rays. When we make a graph of intensity of emitted X-ray, what is intensity? Intensity, brightness, very good, but what is intensity? Intensity is energy per unit area per unit time. So when we make a graph of intensity against wavelength, we find that there is certain lambda minimum below which we don't get any X-rays. So this is say lambda minimum. Then as we increase, look at increasing wavelength, the intensity increases. It reaches a peak somewhere. Then it decreases like this. But certain wavelengths come out in huge quantities. They have very high intensity. You'll get one peak here. Here you'll get even a higher peak. Then a smaller peak here. A little bit bigger peak here. And a little bit bigger. This wavelength is coming out in huge quantity. This wavelength comes out in huge quantity. All these wavelengths come out in huge quantities. Now, this is the graph for continuous X-rays that we learnt earlier. Now, these peaks, they refer to characteristic X-rays. All these peaks, characteristic X-rays. Now question is, why some particular wavelength come out in huge quantities? Their intensity is very, very high. For this, we have to look at the energy levels. The energy levels. This is the K shell, right? Above that we have got the L shell, M, N, O, P, right? You know this. The electrons can be in various energy levels given by this diagram. Now, let us look at a target atom. A target atom will have 2 electrons in the K shell, 8 electrons in the L shell. Right? One more. You have 18 electrons in the M shell. Okay, target is an element with high atomic number and high melting point, like tungsten, molybdenum. Now, high speed electrons are coming and hitting the target. So because of these high speed electrons, some electrons in this target atom will get knocked off, right? So they'll get removed. Suppose this electron is knocked off. Now once this electron is knocked off, a vacancy is created in the K shell. An electron from a higher energy level will jump down to fill this vacancy. If the electron jumps from here to here, this is very close, so this is the most probable thing to happen. We get a particular wavelength and frequency of X-ray, and that corresponds to K alpha line. And this is this peak. This is K alpha X-ray. Now the electrons here are lazy. Then electron from here may jump here directly. Then you get K beta line. This is less probable. So this is lesser intensity, here K beta. Same way, once we have vacancy here, electron can jump from here to here. That is your L alpha line. This corresponds to this peak. This is L beta line. And this will be L gamma line. So characteristic X-ray emission occurs when a bombarding electron that hits a target atom has sufficient energy to remove an inertial electron from the target atom, the vacancy created is filled when electron from a higher energy level drops down to fill this vacancy. This transition is accompanied by the emission of a photon whose energy equals the energy difference between the levels. And that is a fixed wavelength for a particular jump. Jumping from L to K for a particular element will be giving you a particular wavelength, a particular frequency of photon. That's why these things come out in huge quantities. Okay, you get a wavelength here, you will not get a wavelength somewhere in between. So this is a very important thing. This characteristic X-ray is actually the signature of an element. By measuring the wavelength of these characteristic X-rays, we can find out which element is that. And that comes from Moseley's law, which you are going to learn in the next lesson. So characteristic X-ray emission occurs when an electron jumps in the target atom from a higher energy level to a lower energy level. And while jumping, because a vacancy has been created when a bombarding electron hits this target atom and knocks off an inertial electron. Remember, continuous X-rays are produced by deceleration of electrons. Characteristic X-rays are produced when the electrons inside the target atom are jumping from higher energy level to lower energy level.